Today we'll be using our decentralized application to showcase the Spera token created by APT Systems. What we'll do is we'll run through the process of deploying the token contract to the Ethereum blockchain. We'll transfer the token between two parties. We'll mint more token. We'll freeze and unfreeze various accounts. And then we'll showcase how we can burn tokens from the ecosystem. All of these features have been carefully designed by the Spera team to ensure that they create an environment that is secure, but allows users to leverage the functionality of a blockchain solution. Without further ado, let's get started. The first thing we'll do is deploy the token contract to a test Ethereum blockchain. And in order to do that, we'll need to sign the transaction from our private account. Perfect. We get the feedback here that it's been deployed. If we want to take a closer look, we can use a tool called Etherscan. This is a website that actually is able to call the blockchain and pull up different information. A lot of people use this to confirm transactions and whatnot, but we'll use this to interface with our contract address. If we open up that link, we're faced with a page with tons of information. What we're most curious about is just checking that it was successful and that we have the contract address. This is going to be the source of where we interact with. And we'll learn more about this as we go today. Okay, let's demonstrate a transfer. What we'll need is two different addresses with the help of MetaMask. We'll be using account 1, which already has a large number of Spera in it, and account 2, who doesn't have anything. What we'll do is we'll send Spera from one account to the other using our decentralized app. So we're going to be sending from account 1 to account 2. And why don't we send them about 100 tokens. Making sure to confirm the transaction. And waiting for the transaction to appear on the blockchain and become immutable. Okay, now we see that the transaction's been validated and it's been a success. We can actually see the transaction on that Etherscan tool we brought up earlier. So we can see it's the same contract, but now we actually have another line down here which showcases that we sent from account 1 to account 2, 100 Spera. Perfect. We can actually further showcase this by pulling up our account. Go to account 2, take a look. They now have 100 Spera. Okay, let's demonstrate minting. This feature will allow only the admin address to create new tokens by submitting and entering the value, making sure to sign the transaction, and then once again, making sure that it becomes immutable by being validated in the network. Once validated, we can confirm by checking Etherscan, looking at a very similar interface, right? This time we now have the 0 address, which has created new token, and sent it to our admin account, showing the value of the token created. Now, why don't we test the feature that only the admin account can be the one minting? To do that, we'll switch accounts to account 2, the general user. And let's try the same thing. Let's try to mint the same amount of tokens. We'll confirm it and wait for the blockchain to propagate and validate this transaction. Perfect. Now we can take a look and see what we have. We get a response that has failed. Next, we will burn tokens. This does the opposite of minting, and this removes tokens from the ecosystem. Again, only the admin can do the burning, and we'll test both options. But to start, let's burn a number of tokens and see the balance update accordingly. So confirming the transaction once again, making sure that each thing is signed is an extra security method. And now we can see the response that the tokens have been burnt. It's updated in our balance, but let's double check the transaction and see what actually is happening here. So using our Etherscan tool again, you can see the inverse of the minting function, where instead of funds going from the 0 address to our admin account, it's acting in reverse, and it is sending the specified amount of Spera token. Now let's see if the general user is able to burn tokens. Switching over to account 2 and trying the same function leads us to a failed transaction, as intended. Perfect. Lastly, let's demonstrate the freezing and unfreezing of an account. To demonstrate this, we'll freeze account 2, the general user. There's a way to pull an account status to see if it's frozen or unfrozen. And then issuing the freeze command will allow us to see a status change here. Once the status has changed to frozen, we'll be able to confirm that this is the case by opening up the transaction once again. Where we'll see the most impact, though, is when user 2 tries to transfer tokens. So let's go ahead and try that. So we're going to enter account 1's address, and let's send them a fair number of tokens here. Let's sign the transaction, making sure that it's coming from account 2. So we're going to send them one of our Spera tokens. Let's see what happens. Perfect. Once the transaction has settled, let's take a look. As expected, since the account has been frozen, the transaction fails. And we're left with an error log showing that there was a transfer error. And this means that the frozen account will not have any permissions to move tokens around until customer support is able to assist. All of these actions we've made have been saved and stored in the decentralized blockchain, meaning we're actually able to see the full history of every transaction that we did in our demo video, from creating the contract, to transferring, to burning, minting, freezing the accounts, trying to send tokens after frozen, getting error messages where there were issues, and having events for each of these actions identifiable and traceable for auditing purposes, including a snapshot of all the Spera holders. Since we only used 2 accounts in this demo, you can see our admin account here with a large share of the Spera token, and our secondary user who's holding 100 right now.